Hello, everyone. My name is Bob Killen. I am a Research Cloud Administrator for the University of Michigan.
And hello, everyone. My name is Eduardo Arango. I'm a software engineer for Red Hat.
And we are here to present about the CNCF Research User Group. Next slide. So first, I sort of want to get into why. Well, with the people attending this talk, I don't think I actually have to talk about too much of these points, but in the research ecosystem, we've seen an increased use of containers everywhere. And with that has come more complex workflows, and not just for the research process itself, but with enterprises and all sorts of groups sort of getting involved in things like machine learning, things like model lifecycle are becoming much more important. Now, also riding on that, we're seeing much more adoption of things like streaming data and eventing based on that data, something that historically hasn't been done too much in the research field. Additionally, we're sort of seeing greater use of interactive science gateways. These days, people are just expecting to get something like a Jupyter notebook to interact with their data. And sort of like backing those science gateways and data streaming services is the persistent services that are needed to support them. And all of these things actually lend themselves really well to Kubernetes. It gives us a platform agnostic API that aids in the scheduling and management of those different workloads. So why form a user group? Most research-oriented workloads are different. We are different from what you'd run in enterprise. I'm sorry. We are a much smaller subset of users than those that are running enterprise-focused services. Much of what we do is very sort of like a job or task-focused, with potentially hundreds of thousands of jobs, akin to sort of what you'd see at a site running something like Slurm. These are sort of also very resource-intensive, and your like normal bin packing isn't necessarily going to be the best way of running those workloads. We also require more advanced scheduling than what Kubernetes can provide out of the box. The best example of this being MPI, or coordinating the scheduling of multiple pods to launch and run at the same time. Workarounds have sort of been developed by multiple little communities, like there's the MPI operator in Kubeflow, a very awesome up-and-coming project called Volcano that is a sandbox project. There's sort of like several other little things that out there that sort of rely on stateful sets to sort of offer that similar behavior. Now, MPI isn't the only thing. Many environments are large and actually require additional support for things like fair share, queues, and a whole slew of other things when you're running on something like bare metal. And while these things haven't necessarily been forgotten by upstream, they have largely been underrepresented.
And I like that last word because also why to form a user group is to represent us all. So that's what I like from the Cloud Native Foundation is we're creating this user group to share pain points, to have a weekly or monthly meeting to say, it's not working for me, it's failing, and I need some help. And as Bob said, this is a small user group, and we need as much help as we can. So this is a group for sharing success stories like the Project Volcano that Bob also told us, and all the new ideas that are coming from these small groups. And this is a common place so we can share and we can request feedback from others in the same field, trying to make research a little more cloud native. And when I say these small groups, I mean like we have small projects coming out of CERN, like the latest HT Condor operator or the common workflow language now being able to interact with Kubernetes. And we have universities also joining Cray. So it is growing. We have some enterprises, universities, and research institutes join. And the idea is so we can grow this into more people so we can share ideas among the same mindsets.
So we've been involved with Kubernetes for quite some time, and have been able to speak with a lot of research groups over the past few years. Many of these groups are grappling with the same set of problems and developing solutions and workarounds in silos. There hasn't been sort of a strong unifying group to sort of help drive the research computing needs in the cloud native ecosystem. And that's sort of the real idea for this user group, bringing the communities and groups that Eduardo had just mentioned together and be one unifying voice. There have been some various like rumblings and efforts in the past, but also actually sort of came to a head last year at KubeCon EU in Barcelona, where a bunch of us also like met together over lunch for a few days, and we decided that we should sort of make something happen. And originally it was going to be a Kubernetes working group, but over time it evolved into CNCF, into the CNCF user group that it is today. And with that, we sort of, like over those few lunches and later on some of the meetings, we identified some common themes. Some of the big things that stuck out is we don't actually really know who's all doing research on Kubernetes and what sort of research they're doing. Everyone sort of feels like they're off on their own in the dark. And sort of seconding that, there isn't really a good set of best practices for operating like large clusters or clusters that are intended to support a large amount of jobs. The defaults don't support an environment with a larger, a large amount of churn as well. Now, the other thing is like Kubernetes itself out of the box doesn't support running workloads like MPI. The base batch capabilities are kind of lacking there. And while there are sort of like other things, like there's multiple multi-cluster tools out there, most don't lend themselves to the distribution of jobs. They lend themselves to the distribution of like your standard application type deployments. They're very sort of focused on ensuring that, sort of like X number of deployments are across multiple clusters, not X number of jobs are spread evenly across them all. The other thing is multi-tenancy itself is also a problem. Kubernetes isn't really like your sort of standard HPC environment where everyone has a POSIX identity. You're now dealing with application identity. And these are just a few of the common themes we've seen. And with that, we actually decided to start a few initiatives.
So let's talk about the initiatives that have come from the researchers group. So right now we want to highlight these three main initiatives. The first one, as I was talking about communities, we want to know how big this community can be, and we want to know who is using Kubernetes, and cloud native tools overall for research. So at the end of this presentation, we have some links, and we are asking everyone to go into those links and fill some forms, because we want to really know how big is this community, and like the question that you are reading here, what type of workloads you're running, who have deployed what and where. So we want to hear if you are running research on bare metal, if you're running research on the cloud, if you're doing something hybrid. So we want to know that, and we are asking everyone to fill this survey. We also have this index, and we want to grow this index of awesome lists, as every solution right now has awesome lists. And I remember my first awesome list was awesome containers. I remember now. And we want to have this awesome list of projects that can help other researchers to get their job done, because at the end, that's the main idea of this user group. Some random researcher in a random research institute just coming into this group, getting help, getting his research done, saving the world from what's coming, and a researcher can save us. And we want to create this awesome list so they can find things easier. And also one of the good ideas that is coming from this initiative is the book of best practices. And as Bob said, there are a lot of things that are not out of the blue for Kubernetes, and we want to write this guideline for common topics and user stories, best practices, and things that can help from the system admin to the research user to use cloud native tools to get research done. So the Cloud Native Research Workloads book really wants to target system admins, operator, research software engineers, and research support staff. So kind of like in where we are right now, that we don't say system admins anymore. It evolved from system admin to the DevOps guy to the operator guy. Now we say SRE, but it's kind of back to the guy that is dealing with all the issues, the system admin. We want to write this guideline with user stories, with pain points, as I was saying in the previous slides, and really take down from day one to day X what you should be doing with your Kubernetes deployment and how to operate that in a good way, so you don't get into the researchers' workloads, right? Like interrupting runs and executions, and also protecting data, because that's something that is very hard. As Bob was saying, the multi-tenancy on research environments, you all the time need to be thinking that researcher A is not deleting or reading information from researcher B. And we want to make research cloud native with this book. When we say this is, I, I personally want, and we want as a community, to help researchers, teachers, and students to get things done faster, easier, and in a better way. So if we can help researchers, teachers to get things done with containers and have fun, as we are a community having fun making things boring. And if those things are boring, so the researcher and teacher can just use it as a tool and have that as a guideline in a book, that is going to be an awesome project. So cluster operations, the topics we want to touch in this book is configuration management and cluster lifecycle. So which things to install from day one, how to operate them, how to update them, how to upgrade them, how to delete them if you don't need them anymore. So all the life cycle of an application on top of your Kubernetes cluster, we want to write that down as a guideline. Management of clusters on top of OpenStack. So a lot of research institutions are right now using OpenStack. Integration with parallel HPC file system and access management. So it gets very important when you start talking about like MPI and things like that. How can you make your Kubernetes cluster interact via RDMAs and via specialized hardware? So here we are not talking about software, but hardware. How can you enable that specialized hardware to your Kubernetes cluster, exposing GPUs to your Kubernetes cluster in a good way, and manage large scale cluster, right? Like 1,000 nodes. In just so everyone in this cloud native community can make sense of numbers, in a research institution, a research facility of HPC, 1,000 nodes is really just the login node. So in our HPC institution, you start talking about 10,000 nodes, 20,000 nodes, and that's considered like a middle kind of size HPC deployment. So 1,000 nodes is really the login system. So configuration management. There are some things that I was discussing with Bob before this presentation. What tooling work when provisioning nodes? It's really not that easy to install Kubernetes in a bare metal cluster. It's not like when you request to your cloud provider, hey, give me a Kubernetes cluster, here's my credit card, and you get a Kubernetes cluster running, and some dollars left of your credit card. But how to do that in your own cluster, in your own systems, is not that easy. So what tooling to use and how to use it, because you can use different tools, but is not that standard how to use them. How is authentication managed? And for me, this is very important, like authentication and also the security policies for multi-user, multi-tenant on a research cluster, because it gets very messy in multi-tenant environments. So we need to be able to differentiate users, projects. A user can be in different projects, like let's say a professor or a teacher can be in different projects, so he has access to different kind of data. But also there are some researchers that can only read one specific side of the data. So we need to be able to separate that. And there are some things that are right now in place in Kubernetes, but we want also to be able to propose things that doesn't exist yet and how to do them in a good way. OpenStack and parallel file system. Again, we want to write in this book all the good practices, guidelines on how to deploy your Kubernetes cluster on top of a running OpenStack installation. Like, we don't want to get into how to run and deploy OpenStack, that there are books for that. We're running from, you have an OpenStack running, you already read it or your OpenStack books, and this is an extra book on top of those OpenStack books that you're going to read on how to, if you have OpenStack now, how can you then use Ironic to deploy bare metal provisioning? How to, you can integrate with other tools in the ecosystem to put your Kubernetes cluster on top of OpenStack. Also, how to do parallel file systems in the way HPC system ecosystem does it, now in a cloud native way. So we want to write these guidelines in this book. GPUs, this is one of my favorite topics. I am part of the GPU operator and I maintain how to run GPUs for Red Hat. So I'm very passionate about this, and writing guidelines and a book about how to do this is very important. And then helping researchers to enable their GPUs, the new and shiny NVIDIA DGX or whatever, or if you are in the AMD ecosystem, how to do that also. So these guidelines are going to help from the system admin SREs to the researchers to expose the new and shiny GPUs. So then they can run Kubeflow or AI ML research on top of those GPUs. Bob.
Okay. That sort of kicks over to the other side of the coin, not the people necessarily running the clusters, but the people consuming them, and your researchers, your teachers, your students. This might also eventually be like other enterprise type customers that are looking at a dashboard for a report on something. But with all that, we sort of identified a few big key areas. One, Jupyter Hub, probably the number one requested application. Jupyter Hub is commonly deployed at most research sites, and it's quickly becoming sort of the de facto standard for ways to people to sort of like consume the stuff, especially on top of Kubernetes. Now, there have been some issues in the past, and there continues to be some problems specifically around like user identity management. You know, how do I plug into my, you know, Active Directory or LDAP and, you know, provision a pod as that user that can actually like translate to a POSIX identity for that person to communicate with our, you know, campus managed file services. So there have been a lot of issues, especially with trying to, you know, integrate with Kerberos and like canetting and things of that nature. There's also been things like image management problems where you might have a whole slew of different images for different classes and different people to consume. Next, sort of building on top of Jupyter Hub a little bit, is actually Kubeflow and machine learning sort of lifecycle management. And just as like Jupyter Hub has sort of become the standard for things, Kubeflow is quickly becoming sort of the go-to for things specifically related to machine learning and machine learning lifecycle management. It is actually a sort of large collection of tools that have all been bundled together and like integrate really, really well with each other. The Kubeflow team has done an incredible job with that. And, you know, the one thing that's a little bit lacking is like there's a lot of people that are getting up and going, but the best practices around doing so that don't, you know, quite exist quite yet. And there's sort of like some other little aspects of it, like it is possible to make it multi-tenant, but it, you know, the stories around and people actually doing it multi-tenant is I'll say a little bit lacking. People are still like off in the dark trying to do it themselves. The other thing, and you heard me sort of like touch upon this earlier, is like batch computing and MPI. These things are not supported by Kubernetes by default, but there are tools out there that do enable that for Kubernetes. The big one, if you've happened to see me talk about stuff before, you've probably heard me reference Volcano, a CNCF sandbox project that is bringing these sort of like classic batch computing style things to Kubernetes, and it provides things like queues, backfill, and all things that you would find in a classic environment. Okay. The next thing is sort of the various like workflow engine and GitOps. This is a very large ecosystem with a whole slew of different tools. Probably one of the most common ones out there these days is Argo, and it's actually used by like Kubeflow under the hood. But you know, it's not the only one out there. There are many others out there, and some general guidance around what tools exist and how to use them would be very useful. The other thing, and after talking for some time, we had originally like lumped in GitOps in with sort of like workflow engines, since they sort of have a very close relationship with each other. But it's now a large enough topic where it will probably be spun off into its own chapter. And actually, Eduardo has started working on a paper where we will probably see a lot more results from that. I don't know the timeline for it, but sometime soon. So we want to answer these questions on how researchers can like effectively use GitOps. We've seen, what storing everything in Git has done for, the management of sort of enterprise applications, and being able to tie, what iteration of a model to the code, to the data that was run to like produce the result. And we've seen how useful that is. Now we just need to sort of like write a little bit of how more people can do it. Lastly, we sort of have the concept of like data ops, and this sort of, all these things sort of like work off each other and integrate with each other. But like managing data in sort of a cloud native way or cloud native environment is fundamentally different from your classic HPC system. So in your normal HPC system, where you have that parallel file system and everything has a POSIX identity where everyone's logging into like a login node, that doesn't really exist in a traditional way in sort of the cloud native space. So this might be, shifting more people to learning to use like object storage, or, being able to use something like Ceph to be able to mount certain things up to different places. And the other thing is like, how do we sort of store and look at this data and save it in a way that's accessible through like, the workflow engines and all that other fun stuff. So with that, we've sort of covered a little bit of what the group is and what we're trying to do and how important like, this book is. And what we would really like from you is to sort of go and visit some of the stuff we were talking about earlier. So you can help us by going into like the CNCF Research User Group repo and fill out the site survey. If you have a really useful resource on how to do something, please just like PR it into our awesome list. It's super helpful. The other thing is like we have some people have already sort of volunteered to help us with the various chapters in this book, but we still have a lot of sections that haven't been claimed. If you are a subject matter expert in any of this space, please just go and volunteer or reach out to one of us on like the mailing list, and we'll any feedback or information on this stuff would be incredibly appreciated. Would be appreciated greatly. With that, here's a little bit of where to find us. We have the GitHub repo. That's sort of like our central place of tracking of everything, and then our CNCF mailing list. We have 2 meetings a month. The first Wednesday of the month at 11 a.m. CET. That's the more EU-friendly meeting, and then the third Wednesday of the month at 5 p.m. CET, which is the more America's friendly meeting. And with that, I think we will call it there, and now go over to the Q&A that's in like a month. Is there any other comments you want to say?
No, it's okay. I really want to read the Q&A and start growing the community.
Okay. Well then, we'll talk to you in a few.